Hello students, good evening everyone. How are you all? Is everything clear? Video and audio, is everything clear? Is everything clear? Shall we move on? Yes, we'll go ahead. So, this is Krishna Prakash, your KP sir, having 16 years of teaching experience, trained more than 150 batches and ex-faculty of ACE Engineering Academy. Yes, Mrityunjay Singh. In Unacademy, I am going to teach the subjects environmental engineering, hydrology, irrigation, construction materials and management, and open channel flow. So yesterday I have started new batch of GATE and ESE. Open channel flow is going to start. Yesterday open channel flow 5:30 to 7:30. Students enjoyed a lot the subject. They earned a lot of knowledge. So if you want to take plus subscription, use my code KP Civil. While you are downloading Unacademy app, it will ask unlock free classes. It will ask how to unlock free classes. So unlock free classes using the code. Remember what is the code? KP Civil. KP Civil. If you, your friends, your juniors, whoever want to watch free classes, so the code to unlock free classes is KP Civil. Okay. Hello Shivam, how are you? On December 13, the greatest event, Unacademy Combat. What is that greatest event? Online test series. The top difficult and most typical questions in GATE. We are going to give 15 questions for a duration of 1 hour. The most toughest questions in GATE. But while facing that toughest questions, you will get experience of GATE more than GATE level. The same time, you are going to get exciting prizes. Apple MacBook first prize, Apple iPad mini, and Apple AirPods 1, 2, 3 prizes. And top 100 rankers are going to get 1,000 rupees Amazon vouchers. Good evening Ramakrishna, good evening Manoj, good evening Deepak. So everyone be ready to crack Unacademy Combat, compete, crack it, conquer the prizes. I feel my students are going to get the prize. So even for that, if you want to register, your registration code, reference code or invitation code for registration, it will ask, that is KP Civil. It will ask the code, that is KP Civil. Okay. So we are continuing since a week the environmental engineering GATE crash course on all free classes, YouTube as well as Unacademy. So every day 4 p.m. we are continuing since last week. This is the last day class in YouTube. Don't worry, hereafter we are not taking in YouTube, but don't worry, we are continuing classes in Unacademy till December 31st. By the end of December, you are ready to solve any question in environmental engineering. I will make you like this. Clear? By the end of December 31st, it's my promise. You are capable of answering most of all questions in GATE by December 31st. Okay? Done. So yesterday what we discussed? Activated sludge process, ASP. Good evening Deepak. We'll go ahead now. So yesterday we discussed it is regarding activated sludge process ASP. The first formula now, discharge is equal to population into per capita sewage flow, PCSF. Have you heard it? Have you heard regarding it? PCSF. PCSF is nothing but per capita sewage flow. Sewage flow. The sewage entered into the drain after consumption of water by each person. How much volume of sewage every day released into the drainage system per day? Per capita. Capita means one person. Per one person on one day, how much wastewater released into the drains? That is called per capita sewage flow. Good evening, Dhiresh. Good evening. Per capita sewage flow. Now, total BOD. Total BOD. This total BOD expressed in the units kg per day. Total BOD expressed in the units kg per day. Every day Q liters of water released into drainage system, wastewater. Every day Q liters of wastewater released into drainage. Each 1 liter of sludge is carrying Y milligrams of BOD. Each 1 liter of sludge or 1 liter of wastewater is going to carry Y milligrams of BOD. But we need in which units? Kg. So into 10 power minus 6 to convert milligram to kg. To convert milligram to kg. Discharge in liter per day, BOD in milligram per liter, and to convert milligram to kg, 10 power minus 6. That is the total BOD loaded. And here, into aeration chamber. Very good, Manas. Into aeration chamber per unit volume. How much BOD you are loading? This is the total available BOD. Remember, this is the total available BOD. Where you are loading? Into volume of aeration tank. Into volume of aeration tank. Volumetric loading rate, organic loading rate. Clear? Volumetric loading rate, organic loading rate, BOD loading rate. All are same. All are same. Volumetric loading rate, organic loading rate, BOD loading rate. All are same. BOD loaded per unit volume of aeration tank. U. Total BOD is Q into YI into 10 power minus 6. Take this as YI, influent BOD. Take this as YI. YI is called influent. Influent BOD. YI. YI is equal to influent BOD. Q into YI into 10 power minus 6. This is kg per day. Where you are loading this? Tell me. Where you are loading this? Into aeration tank. Aeration tank. So into volume of aeration tank. So we are taking here divided by volume of aeration chamber. Volume of aeration chamber in meter cube. So that you get U, organic loading rate is equal to kg per day into 1 meter cube. Kg per day per meter cube. U, organic loading rate. Q into YI into 10 power minus 6 by V, volume of aeration chamber. But design engineer is going to take U. the value of U is going to be considered by the design engineer from IS codal provisions. He is not estimating that. Design engineer is not going to estimate U. He is getting it from IS code. Then what is use of U? So volume of aeration chamber V is equal to Q into Yi into 10 power minus 6 by U. Volume of aeration chamber V is equal to Q into Yi into 10 power minus 6 by U volume. You are getting. Yes, very good, Manoj. You remembered everything what I taught in the class. Very nice. Then detention time dt, which is called aeration period. Volume by discharge. Remember, volume is taken in meter cube. Discharge to be considered in meter cube per hour. Volume is given in meter cube. Discharge is taken in meter cube per hour. Very important. Food to microorganism ratio. Remember it? Amount of food consumed divided by amount of food loaded. Amount of food consumed divided by amount of food loaded. Amount of food consumed by amount of food loaded. Food to microorganism ratio. F by M. Q into Yi by V into Xi. What is Xi? Influent solids concentration. Xi we are going to consider influent solids concentration. Food to microorganism ratio F by M is equal to Q into Yi by V into Xi. This V into Xi, we consider it as mass of solids. V into Xi, we take it as a mass of solids loaded. Mass of solids loaded. Then what is Q into Yi? Solids consumed. So if influent BOD and effluent BOD also given, if YE, yes, correct Ramakrishna, if YE, effluent BOD given, what is your answer? Formula? Effluent BOD given, then for ASP, not for aeration tank, for the total activated sludge process we are talking. Good evening, Srikandan came late today. For activated sludge process, not for aeration chamber, entire process. Food to biomass ratio, Q into Yi minus Ye. Q into Yi minus Ye by V into Xi. You understand? For activated sludge process, if Ye data in the data for to solve the numerical questions in GATE, effluent BOD Ye also given, then Ye is effluent BOD, this is provided in the data. Then you take food to biomass ratio as a Q into yi minus ye by v into xi. Q into yi minus ye by v into xi. Last one. Sludge is theta c. Same also called as mean cell residence time. The time taken to degrade the sludge. For complete degradation of sludge, how much time is taken by activated sludge process? V is volume only. Ramakrishna, in both cases, V is volume only. No doubt regarding it. V is not changing. V is not changing. Because you are designing aeration chamber, settling chamber with the same volume. You are designing aeration chamber and settling chamber with the same volume. Don't worry. Okay. So food to biomass ratio, two cases, V is same. Done. The time required to 100% degradation of sludge, that is sludge is theta c. On an average, the bacterial cell is resided in the activated sludge process. The time. Average time spent by the bacterial cell in ASP. Average time spent by the bacterial cell in activated sludge process. That is called mean cell residence time. That is said to be mean cell residence time, we are calling. Most important and expected also in 2021. In 2021, most expected also. Remember this. Theta c or mean cell residence time. Theta c or mean cell residence time is equal to mass of solids loaded, divided by mass of solids wasted. Mass of solids loaded divided by mass of solids wasted per day. Every day, how many kgs solids are sent out? Wasted means sent out of the system. So you will get theta c in terms of days. Theta c in days. Theoretically, you can take 10 to 15 days. Theoretically, you will consider it is between 10 to 15 days. Mass of solids loaded by mass of solids wasted per day. We'll take this. V into xi. By QW into XW plus Q minus QW Q minus QW into XE. So this is the formula for theta c, sludge is mean cell residence time, MCRT. Ramakrishna. Every day the solids are going to sludge digester QW into XW. Every day solids are going to trickling filter Q minus QW into XE. Q minus QW into XE. Total solids in the tank at any time, this is a V into Xi. Total solids in the tank, tell me. Total solids in the tank every day. What is total solids in the tank every day? This is only Ramakrishna. Total solids. Total solids in the tank V into Xi every day. So V into Xi is considered. Clear? This is mass of solids loaded. This is mass of solids. So this is mass of solids loaded V into Xi. This is mass of solids wasted. QW into XW plus Q minus QW into XE. Clear? We'll move on now. So these 7 formula. To be frank, I will tell. To be frank, all these are not necessary. Formula number 4, very important. Formula number 4. Formula number 6. And finally, mean cell residence time. Formula number 7. 4th one, 6th one, 7th one. If you remember, enough. Here, 4th one, 6th one, 7th one, if you remember, that is enough. Now we are talking regarding, now we are going to discuss about sludge digestion. Sludge digestion. Sludge digestion has 2 targets. Sludge digestion has 2 targets. Volume reduction strength reduction. The 2 targets in the sludge digestion. 2 targets in the sludge digestion. Volume reduction and strength reduction. 2 targets. So what is this volume reduction, strength reduction? I will give you simple, easy explanation regarding it. If you take a sludge, is it contain only solids? Ram Prasad, tell me. Will the sludge consist of only solids? No. Sludge is a combination of sludge is a combination of solids embedded in liquid wastewater. Solids embedded in liquid wastewater. Very good, Ram Prasad. WW, what I am writing, WW, wastewater. Sludge is a combination of solids with liquid wastewater. In this, solids are, what is the percentage of solids? Solids are 0.25 to 12.5%. Liquid wastewater 87.5 to 99.75%. 87.5 to 99.75% liquid wastewater. 0.25 to 12.5% solids. That is raw sewage. Ram Prasad, what you have given 99.9, that is raw sewage. Raw sewage completed preliminary treatment, primary sedimentation completed. We are taking only sludge after primary sedimentation. You understand? Yes, sir. That has undergone primary sedimentation, only sludge is there. We are talking about sludge. Then Will all solids in the sludge are consumable? Will all solids have been taken by the bacteria? Total 100% of solids are utilizable by bacteria any kind? No, no. Again solids are classified. Again solids are classified. Organic solids, what we call volatile solids, VS. Inorganic solids, what we'll call non-volatile solids, NVS. Solids are classified into organic and inorganic. Organic is VS, inorganic is NVS. Good. 70% organic solids, 30% inorganic solids. 70% organic solids, 30% inorganic solids. Again, within this organic, will all are consumable? Will all are consumable? Good evening, Rudrajay Singh, after a long time. Along this organic volatile solids, will all are consumable? All are not consumable. Biodegradable solids, biodegradable organic solids, utilizable by bacteria. Non-biodegradable organic solids, non-biodegradable organic solids, not utilizable by bacteria. Yes, Rudrajay Singh, I know it. I took one session also, how to prepare 1 week before UPPSC AE. I think you have seen it. So 50% is biodegradable organic, 20% is non-biodegradable organic. 50% is biodegradable organic, 20% is non-biodegradable organic. So this is only food for bacteria. Remaining is not the food for bacteria. Only that biodegradable organic matter is food for bacteria. For example, if you are taking 1 million liter of sludge, if you are taking 1 million liter of sludge loaded into aeration tank, in that around 1000 to 5000 liters only food for bacteria. Food for bacteria. So is that easy to identify that food by the bacteria? Tell me. Out of 1 million liter, identifying 1000 to 5000 liters of food. Is it easy for you, Ram Prasad? I have given 1 million cartoons, bags. In that 1 million bags, only 1000 bags is carrying food. Remaining 1 million bags occupied by waste. Is it easy for you to identify where that 1000 bags are present? No, it is not possible. It is very much difficult. It is very much difficult. So, that is going to be very difficult for the bacteria. Identifying 1000 to 5000 liters of bacterial food within 1 million liter. Within 1 million liter. Kushal, SSC JE, this is not the time to study this much. Maybe they will ask one question, but this is not the time to study regarding this, Kushal. Just go for other topics. You go for BOD, you go for water treatment. That is best. My honest suggestion, you go for water treatment more. You will get questions from it. So we need to reduce volume of sludge by removing water. So by separating water from the sludge, separation of water, volume reduction. If liquid wastewater is separated from the sludge, if liquid wastewater is separated from the sludge, so that sludge is easily identified. You got it? Total maximum volume of liquid wastewater 87.5 to 99% water. If that liquid wastewater is separated, the process of sludge digestion is easy. That is called volume reduction. It occurs, volume reduction is going to take place. Volume reduction is going to take place in 4 phases. Sludge thickening, sludge thickening, yes, strength reduction means concentration reduction. Correct. Correct, Ramakrishna. Solids reduction, organic matter reduction. Strength reduction is solids reduction, organic matter reduction, that is strength reduction. Sludge thickening carried out by separation of liquid wastewater carried out by forces of separation of liquid wastewater carried out by forces of gravity and flotation. Forces of gravity and flotation. That is sludge thickening. Separation of liquid wastewater from the sludge by forces of gravity and flotation. Sludge thickening. Followed by sludge digestion. Sludge digestion, decomposition, degradation, whatever the words you can use, no problem. By stabilization of sludge. What is this stabilization of sludge? Stabilization of sludge is nothing but conversion of organic solids to inorganic. Conversion of organic to inorganic. Where it is going on? Where it is going on? In the phase of strength reduction. It is going on in the phase of strength reduction. Yes, it is sequential only, Dhiresh. It is sequential only. Means strength reduction, sludge digestion, both are same. No change. Both are same. Strength reduction, sludge digestion, both are same. First thickening followed by either strength reduction or sludge digestion, both are same. Just alternate words. Just alternate words. Followed by sludge conditioning. Sludge conditioning followed by sludge conditioning. What is conditioning? Again, separation of liquid wastewater. Conditioning is separation of liquid wastewater by heat or chemical treatment. Separation of liquid wastewater by heat or chemical treatment. Chemical treatment. You understand? Sludge thickening, separation of liquid wastewater by forces of gravity flotation. Sludge digestion, separation of liquid wastewater by stabilization. Sludge conditioning, separation of liquid wastewater by heat or chemical treatment. Last one we are talking. Sludge dewatering. Sludge dewatering and drying. Sludge dewatering and drying we are talking about. So what is going on in dewatering and drying? By solar radiation and filtration. Solar radiation and filtration. Sludge drying beds are going to perform the activity. Solar radiation and filtration, sludgy drying beds are performing the activity. So this is most important theoretical question. Order: thickening, digestion, conditioning, dewatering or drying. What is the function? What are the forces? Function is the separation of liquid wastewater. Forces: gravity and flotation, stabilization, heat or chemical treatment, solar radiation and filters. Then when it is come for strength reduction, again order of strength reduction, most repeated theoretical question anywhere, GATE, IES, SSC, JE, UPPSC, whatever your exam may be, most repeated order of strength reduction steps. First one, acid fermentation. Acid fermentation. Second one, acid regression. Regression, hydrolysis, both are same. Regression or hydrolysis. Regression or hydrolysis, both are same. Very good, Ramakrishna. And as a result of it, methane formation, methane generation. Acid undergone breakdown and generated the methane. Acid undergone methane and generated the acid undergone hydrolysis and generated the methane. Yes, the last step, alkaline fermentation. Alkali fermentation. Last step, alkali fermentation and hydrolysis. Alkali fermentation and hydrolysis. Strength reduction carried out by three phases: acid fermentation, acid regression and methane formation, alkali fermentation and hydrolysis. Strength reduction is going to take place. Order of strength reduction, most repeated question, don't forget about it. Order of strength reduction, very important for your exams. Very important for your exams. So in a single chart you have three questions: order of volume reduction, order of strength reduction, forces involved in volume reduction. Match the following. Three questions you are having in a single chart. Is that clear? Is that clear? Shall we move on now? We'll go ahead. Jayanth, reuse of treated wastewater is simply a theory. We'll discuss it not here, but in Unacademy class we will discuss it, Jayanth. In Unacademy, I will take it because in YouTube today is the last class. After that, in Unacademy, from tomorrow onwards, I am continuing in Unacademy. In that class, we will discuss reuse of treated wastewater. End products of sludge digestion. Sludge digestion is going to give gases, methane 70%, methane 70%, carbon dioxide 25 to 30%, H2S 0 to 5%. Carbon dioxide. Good afternoon, Patil. How are you? Yes, tomorrow onwards only Unacademy class. No class on YouTube. Okay, Dhiresh. Tomorrow onwards only class on Unacademy. No class on YouTube. 70% methane, 25 to 30% carbon dioxide, 0 to 5% H2S. Hello Sharma, how are you? And it produces dry powdered solids, inorganic dry mass, which is used as manure in agricultural field. Dry powdered solids which are used as manure in agricultural field. Clear? And liquid wastewater. Every stage of volume reduction, liquid wastewater is generated now at each stage of volume reduction. So wherever volume is reduced, at each stage liquid wastewater is generated. That liquid wastewater is given to trickling filter. That liquid wastewater is loaded into trickling filter. Clear? Dry solids utilized as manure, liquid wastewater given into trickling filter. And out of these gases, methane. Methane is a high calorific value containing. Methane is a high calorific value containing gas. High calorific value containing gas. You are generating energy. From methane, you are going to generate energy. Because if you are giving 1 kg of volatile solids, VS, you are giving 1 kg of volatile solids to sludge digester. It is generating 0.9 meter cube of gases. 1 kg of volatile solids are going to generate 0.9 meter cube of gases. In this, what is methane? Methane is 70% of 0.9. 70% of 0.9. 0.63 meter cube of methane. So 1 kg of volatile solids are going to give how much methane? 1 kg of volatile solids are going to give 0.63 meter cube of methane. And every 1 meter cube of methane is generating. Every 1 meter cube of methane is generating 5,200 to 5,800 kilocalories of energy. Kilocalories. So this much energy, every 1 meter cube of methane is generating around 5,200 to 5,800 kilocalories of energy. Huge energy generated. So that energy is entrapped properly. The calorific value of methane utilized in the form of energy generation. So energy conservation from the methane is done using these calculations. Clear? We'll move on now. We'll move on. So formula, we are going to discuss regarding formula related to sludge digestion. Formula related to sludge digestion. Formula related to sludge digestion. First one, volume of digester. Volume of digester V. Under general circumstances, we will take V is equal to Vf plus Vd by 2 into T. But if it was given as a low rate digester, high rate digester, calculations are different. Just simply in the question they provided you, nothing mentioned. No information whether it is low rate digester or it is a high rate digester, nothing is provided. Just they asked you to determine volume of digester, V. Vf plus Vd by 2 into T. Vf plus Vd by 2 into T. Vf volume of fresh sludge. Volume of fresh sludge per day. Loaded into digester. Volume of fresh sludge loaded into digester per day. Vd. Volume of digested sludge. Fresh sludge given into digester. Sludge digestion is going on. Organic sludge converted into inorganic. Settled. Organic sludge converted into inorganic, and that is settled in the chamber, in the tank. So that volume of digested sludge is settled in the chamber per day. T. Total time required for decomposition. Decomposition or digestion period. Decomposition, also called, we call it as digestion. Decomposition or digestion period. T. Volume of digester. Got it? Then second formula. For any kind of sludge, it may be fresh sludge or it may be digested sludge, whatever it may be. Volume of sludge is equal to mass of solids by density of sludge. Mass of solids by density of sludge into 100 by 100 minus percentage of moisture content. Volume of sludge is equal to mass of solids by density of sludge into 100 by 100 minus percentage of moisture content. PMC. Percentage of water in the sludge. Water we are not calling water. Technically we are considering moisture content. Percentage of moisture content in the sludge. Mass of solids by density of sludge into 100 by 100 minus PMC, volume of sludge. Clear? Is that clear for everyone? Then percentage of volume reduction. How much percentage of volume is reduced? Because our entire target in sludge digestion is volume reduction only. Our total 100% target is removal of volume. So we will consider V1 minus V2 by V1 into 100. Simple general formula. V1 minus V2 by V1 into 100. Simple general formula. Along with this, we have one more formula. You know it. V1 into 100 minus P1 is equal to V2 into 100 minus P2. These are the four formula needed for sludge digestion. P1, P2. P1, percentage of moisture content in fresh sludge. Percentage of moisture content in fresh sludge, P1. P2, percentage of moisture content in digested sludge. So this is related to sludge digestion. Out of the whole, third and fourth very important for you. Third formula and fourth formula very important for you. Okay? Clear for everyone? So all remaining topics, don't worry. Whatever not covered in YouTube, from tomorrow onwards, every day 1 hour if possible. If you are ready, I am taking 2 hours also. Clear? Remaining topics, actually I am planning for 1 hour. If you are ready, we'll discuss. We'll plan for 2 hours also. But by the end, our target by end of December 31st, all of you must be ready to solve, crack any kind of question in environmental engineering. I will make you like that. But don't miss, you continue in Unacademy, remaining topics. You continue in Unacademy. Don't miss the session. Okay? 3 hours also, Ramakrishna. Okay, good. Don't miss the sessions. So if you want to watch my classes in Unacademy, after downloading Unacademy app, give the code KP Civil, use the code KP Civil, so that you can watch all my lectures. This is a free course unlocking code. Free course unlocking code, that is KP Civil. Dhiresh, you are a plus student or not? Dhiresh, you are a plus student only now. So you have your plus subscription, already I taught it. Solid waste management, already I taught in the plus course. If you want, I will send the link, Dhiresh. You just send a message, we will talk. Okay, you send a message to me, I will send the link of solid waste management which is taught in the plus course. Okay? Okay, Dhiresh? So everyone remember the task you have to do. At least one student can make one of his friend, junior or brother, just to install Unacademy app and use the code KP Civil for free courses. That is your target. I'm not asking you to refer for plus subscription. Just install Unacademy app and use the code for free classes KP Civil. Okay? I'm going to close the session. Done. Thank you one and all. Thank you one and all. We'll meet again tomorrow 4 p.m. Tomorrow 4 p.m. We have a regular class at Unacademy. We'll meet again. Thank you one and all. Yes, Dhiresh will continue. Tomorrow numericals will continue in Unacademy. Numericals will continue in Unacademy. Okay, Dhiresh?